Hi, everybody. I wanted to talk to you a little bit about the topic of multi-threaded unicast um, transmissions. With multi-threading, you need operations that involve what are called sockets. The sockets API is very old. It dates back to early versions of Unix in the old Berkeley software development or BSD days. And people in just about every language are relatively familiar with sockets. Sockets need to have access to an internet address, but in addition, they need access to the port. The port will be something that will accept connections on a server, and once the connection has been accepted, it gets served by a thread. And the reason we use a thread is because you want to be able to manage multiple connection requests. So what happens is you're dealing with an API in an object-oriented environment, and it's called the socket class. And in the socket class, we get an opportunity to time out. With TCP/IP, we expect that the bits will go in the same order in which they come out. Moreover, we expect an unformatted sequence of bytes, or a stream. So the server socket is going to be able to accept a connection, and once that connection is accepted, it's going to return a socket instance. That gets handled by a thread, and then you go back and you invoke the accept method again. This executes atomically, waiting for another request to come in so that the accept can return once again with an instance of the socket. So server sockets essentially have the accept method. The accept method returns the socket instance, and the socket instance is then used to obtain an input stream and an output stream so that the client can pass data in and can have data returned. Typically, the threaded server is going to have many threads. If you don't do this with threads, if you try and do it with tasks, it's almost a certainty that once your server goes live, it will be crushed by repeated requests from multiple clients. This is how things used to work in the early days of PHP and Visual Basic. They had multitasking systems that didn't use threads. What we'd like to do now is take a quick look at a port scanner. A port scanner is going to essentially go to a individual host and look for ports which are willing to accept connections. And we'll go right up to port number 65,535. That's the limit to the highest number that you can have according to the Internet Corporation for Assigned Names and Numbers, also known as ICANN. That's a 16-bit quantity. We'll make a whole instance of a port given the host, the first port and the last port, and then we'll take all of these ports and we'll proceed to feed them into our little port scanner, a multi-threaded system that will then proceed to check to see if the port is available. If the port's available, then we'll be able to report it back, and by using a port scanner like this, we can infer the type of port that we have, and maybe we can figure out what kind of service we're dealing with. So that's kind of important. Sometimes script kiddies will scan for an open port, and they'll say, aha, here's an SSH port, and we'll try and guess some sort of password and user ID, and then we're going to try and use our dictionary of passwords, and if we can get in, then we have control over your system. So we'll keep making up these new sockets based on these ports, and we'll be able to check to see if anybody is able to connect to the port, and if they are, then we can list that port. There are lists of ports in /etc /ports. We can go and look at the services, and here what we see is a thread which is taking as its argument a lambda expression. That's going to be executed as part of the run method, and it's going to do a port scan, a multi-threaded mechanism for essentially looking at every single port and scanning to see if it's available for a connection. So that's a a, a pretty elegant way to go about scanning for ports. And what we'll do is we'll run it. It goes really fast, multi-threaded, and we can see there's ports 8086 is active, 548 is active, 21 is active, 22 is active. 22 we know is SSH, 25 is FTP, 80 is going to be a web server, and here's the list of all the different common ports and all the services that you can get on these various ports. Some of them will allow you to connect with UDP, some of them allow you to connect with TCP, and each of them have well understood functions. So now we're looking over here at the services file, which is in etc. So typically you'd say something like cd /etc, and then you'd say cat services, and here we're going to say grep and look for 875, and we see port 875 is being used for remote quota services. So for a distributed file system, somebody might do an invocation to ask something like whether or not quotas have been exceeded. Here's port 993. It's being used for the IMAP server over SSL, and there are a wide variety of different ports that are apparently open here running services. So this here's a port 5989, and you say, what does that do? And the answer is, I don't know. Let's take a look. So you look at 5989 and you say, aha, it's using HTTPS and using some sort of interesting protocol, which I don't happen to know. mbem, what is this? Some sort of, I'm not even going to guess. So I may have to Google that and see that it's opened and wonder, well, gee, I don't know quite what that does. APC, I bet you that has something to do with the UPS system. APC, that sounds like a product now owned by Schneider. It used to be UPS. Here you can see a number of days my web server's been up, 1,522 days. And the darn thing's like, wow, doesn't seem to crash very often. It's very nice. So there you have it. A little bit of internet programming, and I hope you like my presentation. Thank you.